Hello everyone, this video is recorded to show you some basic skills about operating Etabs and two examples demonstrated. The first one is like this one, and it's quite simple. As you can see, there is only one load, while the second one is a little bit complicated. So after opening the Etabs, the first and very important step is to change the unit. In the following example I am going to demonstrate, I will use the unit of kilonewton per meter, and then open a new model and change the number. Number line in x direction are 2, and in y direction is 1, spacing is 5, number of story in this example is only 1, and the height is also 5, and we choose the grid only. After that, two windows are shown with two different elevations, but for convenience I changed it into elevations 1 for both of them. Now go to define and click material, and to add a new material and name it concrete, and you can change the color that you like, and I will choose green. You don't have to change your data except this one, the weight. Change it into 24.5 and click OK. And the new material concrete is shown here. Go to define again and click frame section and define the beam and the column. For beam, choose add rectangular and name it beam, and select the material of concrete which I've just added, and you can change the dimension any value you like, and I'll change it into 0.4, which is the depth, and the width is 0.5, and the beam is added here. For column, choose add circle and name it column. Again, select the concrete material and change the diameter. This time I'll use 0.8 as the diameter. Now you can find both beam and column are added here. And now we can go to draw and select draw line object and draw lines. Go to property and select beam, which I've just added, and click on the starting point and the ending point, and the beam is drawn. Similarly, select column and draw the two vertical lines. And now select the 2 point for adding support, and go to assign, select join or load and choose restraint. Use find fixed end, roller and hinge support, and I'll choose the fixed end as the support. After that, go to define and select the static load case. We'll only have dead load and one live load, so we don't have to add any load, and just click OK. And now I can assign the load by going to assign and choose frame or line load, and it is a point load. This is a live load. The unit is kilonewton per meter. Select the absolute distance, and the middle part is 2.5 meter, and the load can be any value that you like, and I just enter 50 and then press OK. Now you can see the load of 50 kilonewton is shown in the middle of the beam. Go to Analyze and set the Analyze option. Choose the Exceed Plan, and remember not to select the Dynamic Analyze. Press OK. Now go to Analyze again and run the Analyze, but before that you have to save your work. After analyzing, and you'll see the deformed shape, and you can press start animation to see how it moves, in order to slow down the animation or speed it up. Go to the options and choose more windows. Let's choose 4 windows and change all the elevations into elevations 1. And display each window with different diagram. Go to display and show member force stress diagram and frame force. You can see the shear force diagram of the life load or the bending moment and the dead load as well. And after that, go to display and select only the frame output and press OK. And the table is shown afterward, and you can copy the entire table to the Excel. In the table, you can see the data of live load and dead load, and you can identify them by changing their colors. And as you can see, the value in these 4 columns are all zeroed, which means they're not useful actually. So we can just hide them. And you can find the maximum, minimum shear force or bending moment through this data easily. So this is the end of the example 1. The second example is a little bit complicated since there is not only 1 load but 3, and one is UDL, the uniformly distributed load, and the steps are roughly the same as the example 1 but some are different. Again, the first thing you have to do is to change the unit into kilonewton per meter. And after that, you can add a new model. In this example, number lines in X direction is 3 and in Y direction is 1, the spacing is 5, number of stories is 2 and the height is 5 as well. And choose grid only and press OK. Change all the elevations into elevations 1. Go to define and select materials properties. Add congruent as the new properties and change the weight into 24.5. Then go to define again and choose frame section. Add beam by selecting add rectangular. We have 2 beams this time, so we name the first one as beam 1 and the material is congruent. The depth is 0.4 and the width is 0.3. Select add rectangular again to add beam 2 and material is congruent as well. The depth is this time is 0.6 and width is 0.5. And click the add circle to add column. The material is congruent as well, and the diameter is 0.8. And now we have beam 1, beam 2, and column shown in this table. Then we can draw the lines. I'll draw beam 1 first, which is started here and end here. And then I draw beam 2 at this horizontal line. Lastly, I choose column and select all the vertical lines except the line in the middle bottom, which is this part. We can click the building field options and select line sections for checking. And now column, beam 1 and beam 2, so no mistakes. Then we can hide it back. The 2 support in the bottom part are hinge support. but we want the left hand side one and to be fixed and support. And now the one on the right hand side is hinge support and the one in the left hand side is fixed end. And to move on, go to define and statics load case, and we have that load for sure, and we name it self weight in short form SW this time, and the live load as LL1 and live load 2, live load 3. So altogether we have self weight, live load 1, live load 2, and live load 3. And after that, go to load combinations and we add the new combinations. The first one is only includes self weight, and the second one includes self weight and live load 1. The third one includes in live load 2 and the self weight. And the fourth one includes self weight and live load 3. The fifth one includes self weight and live load 1 plus live load 2. The sixth one includes live load 1 and 3 and the self weight. Seventh one includes live load 2 and 3 and the self weight. And the eighth one are self weight, live load 1, live load 2, and 3. So altogether we have now 8 different combinations. And after that we can select the beam and assign the load on it. Load on beam 1 are point loads. And this is the live load 1. Select the absolute distance, and the first load is on 2.5 meter and the second one is on 7.5. Both of them are 10 kilonewton. Then select the point on the top right hand corner and assign the force on it. And this is a live load 2. Load is on x-axis and is 30. But the load is pointing to the left hand side, so it should be negative 30. The last load is on beam 2, and select it and go to assign. This is a UDL, so I choose distributed. The load case name is live load 3, and select absolute distance, and the UDL only occurs on the first 5 meters, so I type 5 as the distance and the load is 10. And the UDL is now formed on beam 2. Now we can go to the set analysis options and select the XZ plant and untick the dynamic analyze and run the analyze after saving it. And we can watch the animations after running it. Open 2 more windows to see the deformed shape. Change all the elevations into elevations 1, and go to display and select show deformed shape and select LL1 for the first window, select LL2 for the second window, and select LL3 for the last window. And now start all the animations to see how they move. Go to display again and click show tables and select only the frame output. and copy the entire table to Excel, and you can find all the details of cell play, life flow 1, life flow 2, life flow 3, combinations 1 to 8. And again these 3 columns are all 0, so we can just hide it because they are not useful. And actually you can find out the maximum or minimum shear force or bending moment on different loads simply by applying the exact formula, which is equal to maximum and blanket, and you can just select the range and the answer will be shown after entering it. And this is the end of example 2.